Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today, we're going to look at how confidence intervals and significance tests relate to each other. So if we have a sampling distribution here for a given proportion, a p-hat, and then we have our individual, this purple dot represents the individual sample we took. So this is all possible p-hats if we took every possible sample. This p-hat down here, this purple one, is the individual sample that we took. You'll recall that what happens with a confidence interval is, let's say this blue area represents 90%. Here, I'll write this up here, 90% of the distribution of possible p-hats. Well, there's a 90% chance that by random sampling we end up in the blue area, and a 10% chance that we happen to be in either tail and miss that blue area. So we take this width when we're making a confidence interval of the blue area, and we transfer it to the p-hat and center it here. So this is our confidence interval, is this purple bar here. And you can see that anytime our sample falls within the blue area, we capture that true proportion here. That's the middle of the distribution. If we happen to fall outside that blue area, our confidence interval misses that true proportion. Now, for significance tests, what's happening here is we have, let's say we have a two-tailed test here. We're going to take our sample and we're going to say, okay, well, what's the probability of getting our sample or something more extreme? So this green area on the left and the right here in these tails would represent the p-value for an alternative hypothesis that's a two-tailed hypothesis, so a not equals to alternative. And this is how we make a decision whether we are going to reject this null hypothesis or fail to reject, depending on how big this area is. If we get a value that's pretty far out here, we're going to say, hey, this area is pretty small, it's less than 5%. So if we add these areas together and we get less than 5% or less than 10% or whatever our alpha is, then we reject the idea that this is the true proportion. If our sample happens to be in here and there's a high probability of getting our sample, if this is the true proportion, then we would fail to reject it. So that's just a quick review and kind of a visual of how confidence intervals and significance tests work. Well, let's put these two together now. Let's say I had this 90% here, and I create my confidence interval within that 90%. Well, you'll notice that in these tails, if this is 90%, that each of these two green areas here, these two tails, let's move these out of the way, these two tails here would have to add up to 10%. So let's say our test that we're running has an alpha of 10% or 0.1. Well, when we look at our p-hat, our sample, if our p-hat is just barely on the boundary, of that blue area, we're just right here on the edge, you can see that this green would represent the p-value of our hypothesis test, and it would probably be equal to 10% here because it's these two tails that's outside the 90% that's blue. If we move it inside the blue area, you can see our confidence interval is capturing this proportion, and that our green area here, which represents our p-value, the sum of these two green areas here, would be greater than 10% now because it would be inside. So all this green area here and here would be more than 10%. So when the confidence interval captures the true proportion, we would get a p-value greater than our alpha, and we would fail to reject the null. So the confidence interval capturing this proportion and the hypothesis test failing to reject that proportion show that there's an agreement between the confidence interval's results and the hypothesis test results. Now, this relies on that 90% and the 10% for the alpha adding up to 100%. If this was like a 70% confidence interval and a 10% alpha, this would not work. Now, conversely, let's say that we get a p-hat that's out here somewhere. Well, since each of these tails was 5% and now the green is outside of it, we would get an alpha when we added these together that would be less than 10%. So we would reject this null hypothesis that the true proportion's here in the middle. And you will note that the confidence interval now misses that true proportion. We would not capture it. So both the confidence interval missing this value and the hypothesis test rejecting that value are in agreement. Again, this requires that the 90% and the 10% match up for a two-tailed test. This is two-tailed with the two green areas adding up. Well, let's think about for a second what it would look like for a one-tailed test. So if we were looking at a one-tailed test and we were capturing the true proportion over here, that means our area now for our p-value would be more than just the 5% of this one tail. And if we were outside and not capturing that true proportion, that means we'd be less than the 5% of this one tail, because we're not doubling it to add in this value anymore. So we were just looking here at this p-value and this tail of 5%. So for a one-tailed test, either a less than alternative or a greater than alternative, it would correspond to an alpha equals 5% or 0.05. So when a confidence interval directly matches with the alpha and we have a two-tailed test, the test and the confidence interval should coincide and be in agreement, both missing the proportion and rejecting it, or capturing this proportion and failing to reject it. For a one-tailed test, we're looking at half of that. So 90 minus, or 100 minus 90 would be 10%. Half of that's 5. So for a one-tailed test, the 5% alpha would correspond with the 90% confidence interval. To kind of illustrate that some more, if we had a confidence level that was equal to 95%, then for a two-tailed test, a not equals 2, that would correspond to an alpha equals 5% or 0.05. For a one-tailed test, a greater than or a less than, it would correspond to an alpha that was half of that, so 0.025. I hope you found today's video helpful. I know it was a bit of rambling on my part. If you have questions, make sure you reach out to me during class. Thank you for joining us, and have a great day.